Today I am going to discuss the topic of curve fitting and how to fit a second degree parabola to a given set of values. I have already told you that if an equation is given, we can very well draw its curve by putting the values to the independent variable and getting at the same time the values of the dependent variable. But if this is not the case, or we can say if the case is reverse, that if the set of values are given, then it is possible, not always possible, for us to assume what sort of relationship they bear with each other, these variables. So we try to assume certain equations to the given set of values and we try to fit it into a curve. For a given set of values, you can assume that the relation between the variables are straight lines or second degree parabola or exponential curve, whatever. But what you assume, you have to do a sort of calculation on it and to check it mathematically. So for this I'm going to consider one example, an easy example, and I'm trying to show you the methodology of doing it. So let us select this. Let us choose these two variables, capital X and capital Y, which has been obtained from a system, say, and I am assuming that capital X has this kind of values and the values of capital Y's are I have considered an easy example just so that I can minimize the size of the calculations present in this particular problem. Now, since I'm going to fit the second degree parabola here, I'm bound to assume a second degree parabola equation first of all for this given set of data. So I'm assuming that the relationship between these variables y and x are as follows: y is equal to a plus bx plus cx square, and you know this is an equation of second degree parabola. Three unknowns are there, a, b, c. If we can know the values of these variables, we can find out the curve which we are assuming that these two variables will satisfy. To find out the values of these unknowns, we need three equations so that we can solve it and find these values. These equations are called normal equations. So in this case, the normal equations will be the first normal equation will be this. I'm just preceding these terms with a summation. This is one normal equation. The second normal equation, first multiply both sides by variable x. And precede this with a summation. And lastly, You multiply both sides by x square and precede this by summations. So we have got three equations like this. These equations can be simplified and written as follows. We get summation y is equal to summation a. How many terms are there? 5 terms. So this will be 5a plus b is constant, it will come outside the summation sign. C is constant, it will come outside the summation sign. So we get b summation x plus c summation x square. Likewise, we get from this summation xy a summation x plus b summation x square plus c summation x cube, and lastly x square y is equal to a summation x square plus b summation x cube plus c summation x to the power 4. After solving these three equations, we are going to find the values of the variable a, b and c, and we'll put it here and we'll get our desired second degree parabola. Now, by looking into this set of equations, we are going to construct one table so that we can calculate these summations. Summation y, summation x, xy are given already in the question. We are going to introduce the terms like x square, x cube, xy, x square y, x to the power 4, so that we can calculate these terms and we get these equations, the explicit form of these equations. So we first, in our table, we first write this term x, then we write the term xy. Since x squared is present, we are going to write x squared here. Since x cube is present, we are going to write x cube. Since x to the power 4 is present, we are going to write x to the power 4. Since xy is present, we are going to write xy. And since x square y is present, we are going to write x square y also. We are going to put the values of x and y as it is given in the question. So the values are -1, 1, 2, -2, 3, -1, 1, 2, -2, 3, and these values are 1, 1, 4, 4, and 9. Now x squared is square of that. I'm going to put it. This is 1, this is 1, this is 4, this is 4, and this is 9. X cube -1, 1, 8, -8, 27. X to the power 4, 1, 1, 16, 16, -81. xy, so we're going to multiply these two. It will be -1, 1, 8, -8, 27. And we are going to multiply these two, x square y. So it will be 1, 1, 16, 16, and 81. Now we are going to calculate the summation of this. Summation of all this. So these summations have been calculated. The sum of this is 3, sum of this is 19, sum of this is 19. This will be 27, and previously there was mistake. It should be 3 to the power 4, that is 81. So the sum of that will be 115. This will be 27, and this will be 115. So let us jot down the summations here. Summation x is 3, summation y is 19, summation x square is 19, summation x cube is 27, summation x to the power 4 is 115, summation xy is equal to 27, summation x square y will be 150. I'm going to put all these values here one by one. So we get, from this equation we are getting summation y is 19. So we are going to write 19 is equal to 5a plus summation x is 3, so it will be 3b, summation x square is 19, so it will be 19c. Similarly, summation xy is 27, a summation x means 3a, b summation x square means 19b, and c summation x cube means 27c. Summation x square y will be 115, a summation x square will be 19a, b summation x cube will be 27b, c summation x to the power 4 will be 115c. So we have got our equations, 3 equations with 3 unknowns. We are going to solve it and find the values of a, b and c. Then it is easy to solve that by solving these equations we get a is equal to 0, b is equal to 0 and c equal to 1. Solving. Therefore, the second degree parabola obtained in this case is y is equal to a plus bx plus cx square. This implies y equal to 0 plus 0 into x plus 1 into x square. Y is equal to x square. This is the methodology of fitting second degree parabola to a given set of values.